Bright Tuty. Every student matters.
Hello students, let us start the chapter Direct and Inverse Proportions. So we're going to start today in the session. I'll discuss about direct proportions and we are going to practice questions on direct proportion. In the next session, you will find the topic or the concept of inverse proportions and the questions based on that. So let us learn about what do we mean when we say direct and inverse proportions. Okay. Now, starting with the introduction, I'll give you one example. Suppose there is a student or there is a person by the name Mohan. Okay, what he is doing is he's preparing tea. Okay, tea for himself as well as for his sister. So he's making tea for two people actually, one for himself, another for his sister. Now he needs for both of them to make a tea, like 2 cups of tea, he needs water. And water he needs as 300 ml. Okay, 300 milliliter. Then he would require sugar. He requires 2 spoons of sugar. He requires 1 spoon of tea. Okay, and then the milk he requires. So he requires 50 ml of milk. Right, now he is making tea for 2 people. Suppose now he has to make it for 5 people, right? Increasing the number of people, will the quantity, will the amount of water, sugar, tea, milk increase? Just think about it. To make 5 cups of tea, will he increase the amount of the ingredients that he is using for making the tea? Yes, definitely. That means when you increase number of people, right, increase in number of people increases what? It increases the amount, or we say quantity. Right, so see, the ingredients are in direct proportion with the number of people. When we increase the number of people, they are also getting increased, right? So we call it as a case of a direct proportion. Directly proportional they are, right? And why are we using proportional? Because we will consider one of them as, suppose X is the number of people and Y is the ingredients that we are using. So this ratio for him is always going to remain same. Okay, so now see, the second example if I give is, suppose 20 people are working on one assignment. Okay, or I say one project they are about to complete. So if 20 people work, suppose they take 10 days. Okay, 20 people are working on an assignment and they are taking 10 days to complete it. Now if I decrease the number of people, I make that 10 people. Right? So will the work be completed in less time or they're going to take more time? If the number of people is less and the amount of work is same, then definitely what will happen? The number of days will increase because now the number of people is less and the amount of work is that much only. So that will take time to complete by 10 people as compared to 20 people. It will take longer. Now if I say I increase the number of people, I make it as 25 people. So will it take 10 days or it will be completed before 10 days? Yes, it will be completed before 10 days. So here what is happening? You know, when you decrease the number of people, the number of days are increasing. When you increase the number of people, the number of days are decreasing. So this kind of relation or variation is known as inverse proportion. Increasing one decreases the another thing. Clear? So these are what do we mean by direct and inverse proportion. Now just have a look at this example of direct proportion. Here weight of sugar is written and here cost is written in rupees. Okay, now just to see, when weight of sugar is 1 kilogram, the cost is 18. Now if we multiply 1 with 3, that means 3 kilogram we are getting. So we'll multiply 18 also with 3. The price for 3 kilogram of sugar is 54. Definitely 18 into 3 is 54. Now if the price of 5 kilogram sugar we have to calculate, so we have multiplied this 1 with 5 and we have multiplied 18 also with 5, right? So this is also 5 upon 90. And the next one is 6. Okay, so we have weight of sugar is 6, so 1 is multiplied with 6, then we have 18. Right, so cost of 1 kilogram of sugar is 18. 18 multiplied with 6 will give us 108. Getting it? Now the next thing, we have to calculate the cost of 8 kilogram of sugar. So if the cost is 18 rupees per kilogram, for 8 kilogram it will be equal to how much? It will be equal to 144. Now the last part, when weight of the sugar is 10 kilogram, what will be the cost? 18 into 10 is 180. Clear? So what is the thing that we observe here? We observe that 3 upon 54, 5 upon 90, 6 upon 108, 8 upon 144, 10 upon 180. These are all equivalent fractions of 1 upon 18. Right? When you convert them into simplest form, you're going to get 1 upon 18. 3 upon 54, cancel it with 3. 3 ones are 3 and 3 eights are 24. So 1 upon 24 every time you are going to get. That means we see, if we consider weight as x and cost as y, the ratio of x upon y, right, this always remains a constant fraction, that is 1 upon 18 here, and we name it as k. This k is known as constant of proportionality. Constant because it is exactly same, it's a fixed value. And why proportionality are we using? Just to see, all these fractions are equivalent, right? So I can just name it as x1 and y1, the second one as x2 and y2, and x3 and y3 up to so on. So I can say x1 upon y1 is equal to x2 upon y2, because I know this ratio is always going to be same when converted to simplest form. These are just the equivalent form of the first one or the second one, right? So this is how we can use it. So we say when x and y are in direct proportion, x upon y is equal to k, or we use this relationship x equals ky. Clear? So if we are given one of the items quantity and the constant of proportionality, we can calculate any other. So or the two items quantity are given, the values for x and y are given, we can calculate the constant of proportionality. So this is what is known as direct proportion. Clear? Increasing the weight increases the cost of sugar, right? Direct proportion they are. Now here if you see, there is a question. It is asking you, you have to observe the tables. So here is one table, the rest we will be taking up. Find if x and y are directly proportional. So see, let us try and calculate the constant of proportionality. That means the ratio of x upon y should always remain same. So the first one, 20 ones are 22s are 40. Yes, we are getting 1 upon 2. 17 ones are 17 twos are. This is also 1 upon 2. So we are actually getting the values of k. 14 ones are 14 twos are 28. Yes, 1 upon 2. 11 ones are 11 2. So 1 upon 2, 8 ones are 8 twos are 16, 1 upon 2, 5 ones are 5 twos are 1 upon 2, 2 ones are 2 twos are 4, so 1 upon 2. So is it going to be same? All the ratios are equivalent form of the other, right? That means when converted to simplest form, they are giving us the same answer, 1 upon 2. That is the simplest form of all of them. So this is the value of k. So here constant of proportionality is 1 upon 2, and yes, they are directly proportional, right? X and y are directly proportional. Next here if we see x and y are given, we have to again identify whether they are in direct proportion or not. So let us cancel 6 and 4. 2 3s are 6, 2 2s are 4. We get 3 upon 2. Second one, 2 5s are 10, 2 4s are 8, 5 upon 4. Just by solving the first two only, we can say x and y are not directly proportional. The reason is the constant is not same, right? Constant is a fixed value, the ratio should always be same, but here in this case it is not same, it is changing. And we know x upon y is always going to be a constant number, it will never change, the ratio will always remain same, so they are not directly proportional. The next part, if you see, let us try in this. 5 ones are 5 threes are, yes, we get 1 upon 3. 8 ones are and 8 threes are 24, 12 ones are, 12 threes are, we are getting 1 upon 3. Let's see next one. 15 ones are, 15 fours are. Here it is changed, right? So these are not directly proportional. X and y are not directly proportional. I hope the concept of direct proportion is now clear. How to check whether two things are, or two items are, or whatever is the given in question are, two variables are, right, they are in direct proportion or not. Here if you see, there is one very good question. They have given us the value of principal, they have given us the rate, they are asking us to fill the following table and find which type of interest, simple or compound, changes in direct proportion with time period. That means interest and time period, they should change directly. That means the ratio of time and simple interest, it should remain same. Time and compound interest, it should remain same. In which case it is same, that we have to find out. They have given the formula for simple interest, that is P into R into T by 100, and the compound interest. How do we calculate compound interest? Amount minus principal. So amount formula is written here. Okay. How do we do now? How are we going to calculate? Just see. So the first one, when t is equal to 1, what is simple interest? It is P into R into T. P is 1000 into R is 8 into time is 1 divided by 100. You see what we get? We get 80. So here I am putting 80. When t is equal to 2, that means time period is 2 years, we get simple interest as 1000 into 8 into 2 upon 100, zeros getting cancelled, we have 160. 160 for 2 years. When time is 3 years, so simple interest will be 1000 into 8 into 3 divided by 100. So we get 240. What are we getting? 240. So is this ratio same of time period and simple interest? Just check. It is 1 upon 80. Cancelling it, 1, 2 ones are 2, 2 8s are 16. Yes, it is also 180. And cancelling it, it is also 1 upon 80. So yes, time period and simple interest, they are in direct proportion, right? Let us calculate about compound interest. So for the first, when t is equal to 1, we'll calculate the compound interest as P is 1000 into 1 plus 8 upon 100 to the power 1 minus 1000. So we can just take 1000 common. 1 plus 8 upon 100 minus 1. 1 and 1 got cancelled. 100 getting cancelled with this. 8 into 10 is 80. So here what we will get? 80. For t equals 2, we get compound interest as 1000 into 1 plus 8 upon 100 whole square minus 1 when we take 1000 common. So you know, when you are going to solve it, you'll get 108 upon 100 whole square minus 1. Right, solving it gives us 166.4. 166.4 approximately we're going to get this. Now if we are getting this, can we say that this is a case of direct proportion? Just see, when time is 1 and compound interest is 80, the ratio is 1:80. But the next time we have the ratio as 2:166.4, cancelling it doesn't give us 1:80. It is going to give us 1 is to more than 80. Right, so these is not in direct proportion. Just by solving the two numbers we can say, right, what is in direct proportion then out of these two type of interest? Simple interest is in direct proportion with time period. Clear? Okay, moving ahead, I have one more question. It is asking, the cost of 5 meters of a particular quality of cloth is rupees 210. Okay, the cost of 5 meters. So we have been given the length of the cloth, that is in 2 meters, and we have been given the cost of it, and cost is given into rupees. So what they have given, when the length is 5, and the cost is 210. You don't need to write the units here because units we have already mentioned. Okay, so when you are going to form it, they are asking you to tabulate the cost of 2, 4, 10 and 13. So 2, 4, 10 and 13. So this you have to tabulate, and 2, 4, 10, 13 meters of clothes of the same time. So we have to write the cost here. So every time whenever they ask you to do that, you are going to form a table. Okay, you can use your scale to form it. Now we know 5 upon 210. Let us represent this with x and this with y. That means x represents the length of the cloth, y represents the cost of the cloth. Right? To avoid the confusions, you can just write x is length of cloth, y is cost of cloth. Okay, now we know the cost of 5 meters of cloth, that is 210 meter. So let us find the ratio x upon y. What does it give us? 5 upon 210. You can simply solve it also and directly keep it this. So this is our k, that is constant of proportionality, and we know when we increase the length, definitely the cost will increase. So this is a question of direct proportion. Now when x is 2, we have to calculate y. We know x, y, and we know now k. K is always going to be same. So I can just write it as x1, or let us represent it with y1, y2, y3, y4. These are the values that we have to calculate. So for the first one, I will write x1, that means x upon y, which is 5 upon 210, is equal to 2 upon y1. Why are we writing that? Because they are in direct proportion with each other, right? So this ratio is in proportion with this ratio. That means two ratios are equal, then only they are said to be in proportion. So we can equate them. Also 5 upon 10 is the value of k. So we are writing the next x and y and equating it to k, because all of them give us the same value of k. Now cross multiplying it, 5y1 is equal to 2 into 210. So y1 is equal to 2 into 221 into 10. 210 can be written as 5 into 2. So we have 2 2s are 4, and 4 into 21, just see 4 1s are 4, 2s are 8, we get 84. So the cost for 2 meters of the cloth is 84. Definitely when the length is less, okay, the cost will also be less. Okay, now similarly we have to find for all. Now the next one we can write 5 upon 210 equals 4 upon y2. So now this is not compulsory that you always use 5 upon 210 and then equate it to something. Now because you have got 2 upon 84, that can also be used, because that is also going to give us the same answer when converted to simplest form. So 5y2 is equal to 4 into 210, y2 is equal to 4 into 210 upon 5. 5 1s are, 5 4s are 20, 5 2s are 10. So y2 will be equal to 4 2s are 8, 4 4s are 16. We get 168. So the cost for 4 meters of the cloth is 168. Now can you calculate the third one? Definitely 5 upon 210 equals 10 upon y3. So 5y3 is equal to 210 into 10. So y3 is equal to 210 into 10 upon 5. 5 2s are 10. So we get 20, and 2 1s are 2, 2 2s are 4, 420. So 10 meters is double the length of this. So price is also doubled. It has become 420. Clear? And the last one, 13 to y4. Can you just try it independently in your notebook? I hope you can do it. Okay, so you will be writing 5 upon 210 equals 13 upon y4, and you can get the value of y4. Let's move to the next question. In this question it is asking an electrical pole. Okay, there is an electric pole 14 meters high. So height is given to us as in meters, and it is 14, and cast a shadow of 10 meters. So we will just represent it with the length of the shadow also in meters, and it is given as 10 meters. Now they are saying find the height of the tree. What we have to calculate? Height of a tree that casts a shadow of 15 meters. So shadow I am writing here under similar conditions. So if the conditions are similar, the ratio will remain same of the height and the length of the shadow. So we can write 14 upon 10 is equal to, let us make it as x. Okay, so x upon 15 X is what? X is the height of the tree. So 14 into 15 would be equal to 10x. X is equal to 14 into 15 by 10. So X is equal to, let us cancel it, 5 3s are, 5 2s are, 2 7s are. So 7 into 3 is 21. So 21 meters. Right, this is the length of the, or we say the height of the tree, and it casts a shadow of 15 meters. Clear? So this is how we do it. Now next part here, they're saying if the weight of 12 sheets of thick paper is 40 grams. Okay, so the number of sheets is given to us and weight of sheet is given. Right, so number of sheets is given as 12 and thickness is given as 14 and it is given into grams. Okay, now they're asking how many sheets of the same paper. We have to calculate the number of sheets. Would weigh 2.5 kilogram. So 2.5 kilogram is 5 upon 2 kilogram, but here it is in grams, so we'll also convert it into grams. 5 upon 2 into 1000 grams, right? 2 ones are, 2 5s are 10, 0 0. We get 2500 grams. So it is 2500 grams. Now to calculate is definitely when the weight is more, the number of sheet is also going to be more. So 120 upon 40 can be equated to x upon 2500 because this is a case of direct proportion. Now solving it, what are we going to get? Just to see. We get 40x is equal to 2500 into 120. So x would be equal to 2500 into 120 divided by 40. 4 ones are, 4 threes are 12. Right? Okay. One more thing. Just see. We got it as 5000 upon 2, right? 2 5s are 10, 0 0, 2500 gram we have. So solving it now, what do we have? We have 120. Okay, here just to see, it was not 120. What is it? It is just 12. Right, it is not number of sheets as 120, it is 12. So I am changing it, so this 0 will not get cancelled. Okay, now solving it further, just see, this 0 will get cancelled with one of the 0 of 4. 4 ones are, 4 threes are 12. What is the answer that we get? We get 750. So this is the number of sheets. What is the number of sheets? 750, whose weight is 2.5 kilogram, or we say 2500 grams. Clear? Next question. If you see here, they're asking, there is a train and it is moving at a uniform speed of 75 kilometer per hour. Okay, but in the question, kilometer is there, but the time is there for minutes, so we'll also write into minutes. So we'll form a table. Distance we will write, that is in kilometer, and time we will write, that is we'll going to write in minutes. Now we have been given that when the distance is 75 kilometer, the time taken is 60 minutes. In the first part of the question, they're asking how far will it travel. So distance is asked when it will travel in 20 minutes. Distance travel in 20 minutes, let us name it as x1. And in the next part, it is asking find the time required. This one they are asking. So we'll represent them with x and y. That means x represents the distance, y represents the time required. So we have to find the time when to cover a distance of 250 kilometer. Right, so this kind of tabular form we will get, and in the first part we will write 75 upon 60 is equal to x1 upon 20, because you know as the distance is increased, time required will also be more, so this is direct proportion, so we can equate them. Now 75 into 20 is equal to 60 x1, and that gives x1 as 75 into 20 upon 60. 21s are, 23s are, 3 ones are, 3 2s are 6, and 3 5s are 15. We get 25. So in 20 minutes it will cover 25 kilometers. The second part of the question asks the time required. So we can say 25 upon 60 is equal to 250 upon y1. You can use this, also you can use this. Like you got x1, that is 25 upon 20 equal to 250 upon y1. Right? That also we can use. So 75 y1 is equal to 250 into 60. So y1 would be equal to 250 into 60 divided by 75, right? 15 fours are 60, 15 fives are 75, 5 ones are 5 fives are 25, 0, 5 fours are 20, 200. So to cover a distance of 250 meters, it requires 200 minutes. The time required will be 200 minutes. So I hope now you are understanding how to attempt the questions. Moving ahead, if you see here, the scale of a map is given, and it is given as 1:3 into 10 to the power 1, 2, 3, 4, 5, 6. Just see 1, 2, 3, 4, 5, 6, 7 zeros we have. Okay, 7, 3 into 10 to the power 7. Then they are saying the two cities are 4 centimeter apart on the map. That means the map distance is 4 centimeter. We have to find the actual distance between them. Okay, so what we are given the map distance, and we are given the actual distance. Map distance is when it is 1, the actual distance is 3 into 10 to the power 7. So they're asking when the distance is 4 centimeter, okay, what will be the actual distance between the cities? So definitely this is a case of direct variation or direct proportion. We can say 1/3 into 10 to the power 7 is equal to 4 upon, let us make it as y. Okay, so y is equal to 4 into 3 into 10 to the power 7, that comes as 12 into 4 to the power 7. So what is the answer? 12 into 10 to the power 7. Correct? This shows that when the cities are 4 centimeter apart on the map, see, definitely the distance, actual distance is going to be very much larger than the number which is there on the map. The reason is, on what is a map? What is mapping? If I'm doing the mapping of a city or the surroundings, what I'll do is on a piece of paper, the complete city is represented there with distance, right? And the city is actually a very large area, so that to make that on map, we make the distance less and we keep a ratio between actual distance and the map distance. Okay, so using that we can find the actual distances between them, as in this case we have calculated. So now I hope that this question is clear, the concept of direct proportion is clear, and how to apply it to the question is clear.